Okay, in this next tutorial, I'm going to get into structures. If you don't know what structures are basically a derived data type. It consists of data components. So just say, for example, an integer. An integer is a derived data type. An integer is a data type created in the compiler. A char is a data type created in the compiler. Boolean is the same thing. When we make a struct, that's kind of like saying I want to make my own data type. Say if you have a student, right? Say you have a student, and say he has a student number, right? So okay, so he has a student number and he has a name. Without a struct, how else could you identify this? Say you wanted to keep this in a data table. How else would you stick this stuff in a data table? You couldn't make an array, because an array is either only one type. If you had an array, how would you do this? You can argue that you can make a 2D array, but an array can either be all int or an array can be all chars. There's no possible way you can make an array that holds both integer values and char values. So that's why a struct comes, and that's why it comes in handy, because you can have also number members and name members. You can also have functions that are just native to this structure itself. Just like an int has these functions, right? An int, you can add in with an int, you can subtract, you can divide, right? You can multiply. Those are the functions within an integer derived type that you can use with, okay? Just like it's like its own function. It's like int has its own functions with the plus operator. So it has a function to handle this operator, has a function to handle that operator. Any operator like this, a modulus, each one has its own function. When you declare a struct, first start with its keyword. So you first start with this. You go on with its name. In this case, it has to be capitalized. So I have student, and then inside the scope. The scope is between these French braces, and you have to end it with a semicolon. Okay. So this is one of its member types. I have an int number and a char name. You can also do double cost or whatever you want. You can do whatever you want. It does not really matter. Okay. If I wanted to access one of these members inside my main function, first I have to simply create a name for my struct. Okay. Over here, the name student is just like saying integer, int, just like saying char, just like saying double. That's what student's like. So picture this. The compiler has a set instructions to identify an integer as a data type. It has its hidden instruction. It has its name, which is the integer, and then it has its name, variable name. So var name. Okay. In the struct's case, instead of having these hidden instructions sent by the compiler, we have this. We have our own struct keyword, which we have to identify, right? And then, after we have that struct keyword, we have the type of variable. So the variable type, in this case, is student. Because this variable type contains these members, right? Contains these members. So, just like an integer would carry a number, the student can carry a number, it can carry a name. So it can carry both of those. And we can individually access each of those members. So student, and then we have its name. So let's make a name for the student. So the type is student, okay? Type is student, and let's just make a student called Mike, okay? And we have to remember that when we declare a instance of Mike of student, of the type student, you have to specify that it's a struct. Okay? So we've specified that's a struct. Once the compiler sees a struct keyword, it says, hey, I gotta define what this is. So it looks around and looks around, okay, so struct, okay, student, okay. Now the compiler's okay. So it identifies this with this, then it could assign this and this, whatever name you call it. So we have Mike. Okay? Now, say Mike, right? Mike's a student. Mike has his own number. Mike has his own name. It changes the course name so it's a little bit more easier to understand. So it has its own course, and his own student number. Okay. Now, if you wanted to give a value to course and student number at the same time, we can simply do this. We can simply do Mike is equal to, right? In French braces, we can do a student number, which could be like 1, 2, 3, 4, 5, and then we could just simply do his course. His course could be, okay, chemistry. So what this does is it assigns the value of 1, 2, 3, 4, 5 to Mike at NO and chemistry to Mike at course. Okay. So let's just compile this and see what's the deal with this. Also, student is the struct as integer is the hidden instructions. Okay, so what the compiler defines as an integer, a struct defines as a student. And what Mike is to student is what variable name, whatever the integer variable name is, so number is to int. So just how you guys get that through your heads, because just like you do with an integer number is equal to 26. Okay, you can do that. Just like you can do struct student Mike is equal to this. Just like integer number is equal to 26, you can do student Mike is equal to this and this. Because student Mike has these two values, number has a value of 26. You go to the student instance, has a number, has a course, Mike has a number, Mike has a course. Let's just compile this and see if it's all in good working order. We can actually print out Mike at each instance. To access Mike at number, we just simply do Mike.no. So if we were to see out Mike at number, right, we can do that. Simply do that. Let's see out both. So we can simply do this. We can do cout Mike.no, which would give us 1, 2, 3, 4, 5, a space, and Mike.course. Let's do a new line. So we're going to do a new line and then Mike.course. So you see we have 1, 2, 3, 4, 5. It just prints out over here, Mike no. And we have chemistry as the course name. Okay? Next, we can do a lot of things with this. We can create an array of structs of Mike. Okay, just say we have struct class, and we have the we have the grade number. Let's have the int grade, the student. So as a percentage maybe, and we can have char student name. Okay, so each member of the class of this class in the school, okay, we'll have an instance of a student. So let's just do struct class students, and let's give them 20. So give 20 values. Okay. So the variable type is a class. Okay. Just like a variable type could be an integer, the variable type is a class. Same thing. And the variable name is students. Okay. Just like you do this, just like you do int. Okay, numbers 20, you can do struct class students 20. 20 numbers, 20 students of this data type. And each data type has a grade and a student name. So once we made this, we can actually do input as well if we'd like to. So, for example, let's make a loop over here. Do something like cout, enter the student grade along with the student name. Okay, and then we can make a loop or something. We can do for int x is equal to 0. Okay, x is less than students, or something like 5, and x plus plus. And what we can do is we can cin students at indice x dot the dot operator to access one of the members dot grade. Okay, and we can do a cin students x dot student. Okay, so after that we can simply do that and recopy this, make a y value to print it out, and we can do cout so what I'm doing is I'm taking input for the grade member and the student name member for each value of students, for each array indice of students until I get to 5. So I have 5 students total. I'm taking in 5 grades, I'm taking in 5 student names, and then I'm outputting uh, the grade and the student name. Okay? So I entered that stuff in, and it's hard to understand what happened here, but 26 Bob, 78 Freddie, 90 Jack, 50 Ray, 99 Janice. Um, so you can manipulate them however you would like. You could send these to functions. I want to get into that in my next video. So practice around structs. Get to know structs, because structs are your friend, and structs are very useful. See you in the next video.